Dear students, in this video, I'll be dealing with the neuromuscular transmission. In the previous video, I've explained about the generation of the action potential in a motor neuron. That is one of the steps in the neuromuscular transmission. So, what is the next step in the neuromuscular transmission is about the synthesis of the neurotransmitter, their action, how they act, okay, and the degradation of the neurotransmitters. So your specific learning objectives are synthesis of acetylcholine, release of acetylcholine, binding of acetylcholine to the receptors, generation of muscle action potential, and the degradation of acetylcholine. About the synthesis of acetylcholine. Acetylcholine is synthesized in the presynaptic membrane, the neuron, where the acetyl coenzyme A is obtained from the glucose metabolism, and the choline, which has been obtained from the dietary sources or due to the degradation of the acetylcholine, which has been recycled. So this choline, which has been obtained under the enzyme, that is cholinesterase enzyme, which catalyzes the synthesis of acetylcholine. So once this acetylcholine is synthesized in the body, in the neuron, it gets stored in the synaptic vesicles. And once it is stored in the synaptic vesicles, these synaptic vesicles, they fuse with the presynaptic membrane terminal. This is under the influence of the calcium entry, increased entry of the calcium ions. How there is increased calcium entry? This is when there is a generation of an action potential, there will be increased calcium entry. So this calcium has got a crucial role in the various steps in the fusion of this synaptic vesicles with the presynaptic terminal. As a result, there will be release of the acetylcholine into the synaptic cleft by exocytosis. So that's how the acetylcholine is synthesized and it is released into the synaptic cleft. Okay, so now the acetylcholine is synthesized and it has been released into the synaptic cleft. And in the synaptic cleft, we have the receptors. Okay, the receptors where acetylcholine binds. So which is the receptor present in the synaptic cleft? Which cholinergic receptor is present in the neuromuscular junction? Yes, it is the nicotinic receptors, NM receptors, which is present in the synaptic cleft. So once this acetylcholine is released into the synaptic cleft, it binds with this nicotinic receptor, which is present in the synaptic cleft. So this nicotinic receptor, it's a pentameric structure. You can see here, it's like a petals of a flower. It has got 5 binding sites. Okay, so it is a pentameric structure. It's an ion channel which has got 2 alpha binding sites, 1 beta, 1 delta, and 1 gamma binding site. So acetylcholine, it binds to this alpha. Okay, so alpha binding site, it binds to this alpha binding site. Acetylcholine binds here. So what happens when acetylcholine binds to these sites? Once acetylcholine binds to this alpha subunits, what happens? There will be opening of the ion channels. So which channel is getting open here? That is the sodium channels. There is opening of the sodium channels. So what happens when there is opening of sodium channels? There will be depolarization. Simultaneously, there will be, the efflux of the potassium ions also will happen. Okay, so because of this influx of the opening of the sodium channels, there will be depolarization. There will be generation of the certain potentials, action potentials because of the depolarization, which lead to the excitatory postsynaptic potentials. Okay, and this contributes to the neuronal depolarization and signal propagation. Okay, so in the muscle cells, what happens? There will be an activation of the nicotinic receptors at the neuromuscular junction, which then triggers the muscle contraction. So that's how there is generation of muscle action potential. Okay, so these are the processes how a muscle action potential is generated. Now, how the acetylcholine is getting degraded or it is getting hydrolyzed in the neuron. So it is the action of this acetylcholine is terminated by acetylcholine esterase enzyme. So it rapidly hydrolyzes the acetylcholine into acetate and choline, and this choline is the one which has been again recycled or it has been taken back, where for the further again the synthesis of the acetylcholine. So this terminates the action of this. So hydrolysis of the acetylcholine by acetylcholine esterase enzyme terminates the action of acetylcholine on the nicotinic receptor. So the breakdown, it prevents the continuous stimulation of the postsynaptic receptors and terminates its action. And the receptors, what happens to the receptors? They return to their resting state. So it can prevent the sustained depolarization of the postsynaptic membrane. Okay, so this is how the neuromuscular transmission happens. So that's all about this. So further about the excitation, contraction, coupling, various types of muscle contractions, all those topics will be taken by my colleague Dr. Deepa. So thank you students, happy learning.